This is a rock, which I'm sure that we all know falls under the category of a solid, but the question I want to ask is as follows. Does this rock have a crystal structure, or is it an amorphous solid? To figure this out, we need to look at the definition of a crystal structure. Well, the definition of a crystal structure is an object that has a uniform, regular pattern of atoms within it. All right, cool. We know that a crystal structure has to have a uniform, regular pattern of atoms, but we can't observe that by just regularly looking at this rock with that definition. But we know from a study at BYJU that crystalline solids tend to have a more rigid structure and appearance, and their shape does not distort upon mild force. However, amorphous solids have nice smooth curves and textures, and their shape is sometimes subject to change and distort upon mild forces. As you can see, when I press down hard on this nice rigid rock, its shape does not change at all. Although rocks, stones, and other earthly minerals can be either crystalline solids or amorphous solids, my studies on this rock in particular lead me to believe that this is indeed a crystalline solid and, in result, has a crystal structure. Now that we know the science behind this rock, let's try to find its density. But let's head inside to do that. Now, the definition of density is the amount of mass per unit of volume of a material. In order to find the density of this rock, we need to use the formula mass over volume. Now, after all, it's not that hard to find the mass of this rock because all we need to do is weigh it. Now, looking at the scale, we can tell that this rock weighs 24 grams. That was easy, but the problem lies with finding the volume of the rock. If the rock had a nice uniform shape, it would be easy to calculate the volume. But since it's very rigid with countless edges, it's going to be challenging. This is where liquid comes into play. Here I have a beaker filled to the top with water, and as soon as I place this rock into the water, the rock will displace the same amount of volume of water as volume in this rock. Since we just used the displacement rule, if we take the mass of this rock and divide it by the volume of water that we have left in this bowl, we will be able to find the density of this rock. And now it's time for a couple fun educational experiments. Moving into surface tension, here we have a jar that looks like it's filled to the brim, and it is, but we can actually put more water in it. This is because of surface tension, and water molecules will always attract to their neighbors and other water molecules. Since there is no water above the top of this lid, all the molecules are pushing and pulling back into the jar, so it allows it to go over the edge, and what should be overflowing is actually still in the cup. Our next experiment is with buoyancy. In water, there is a buoyancy force. And the buoyancy force is a force that acts opposite of gravity and takes part of or all of an object's force and pushes it up rather than down. Now, if the weight of an object is greater than the buoyancy force, the object will sink and fall to the bottom. But if the weight of the object is less than the buoyancy force, the object will float and stay on top. Here I have an exercise band. And when I stretch it, tension is created. But as I let go and it comes back, it starts to compress as it creates slack. So what's that thing called atmospheric pressure? Well, all around us and invisible to us is a layer of gas. And whether you know it or not, this layer of gas is what enables us to drink fluids through a straw. You see, the atmosphere is always pushing down on the liquid and pushing through the straw. But as soon as I start to suck on the straw, I reduce pressure inside the straw, and the water wants to escape that pressure that's getting pushed on it. And where is it going to go? Well, it's going to go where I'm reducing pressure, which is through the straw. Aren't you so glad for physics? And finally, plasma is our fourth stage of matter. Plasma can be defined as an electrified gas, and a nice visual representation of plasma is the aurora borealis. This happens when plasma interacts with gases in the atmosphere, which gives us a beautiful light in the night sky.